Oh, yeah.
Okay, everybody. We're going to finish this last part up with motion perception. Okay.
You see that video on Matt Stoney the other day? 12-pound baby.
Okay. All right, here we go. Motion perception. Okay, so we've already talked about the Gestalt grouping principles, depth perception. Now we're looking at how we perceive motion. And motion is largely depth. Okay, so what we're looking at here, so I have Smalls playing catch really successfully here. Okay, so here's what happens. Objects that are shrinking appear to be retreating. So if we're playing catch with a baseball, okay, as I'm throwing the ball, okay, the ball appears farther away. Okay, so it's going away from me. I'm perceiving that as motion. So then objects, okay, that are getting bigger, they're approaching me. Okay, so I was trying to find the GIF. I didn't look very hard of him getting hit in the eye, okay, with the ball. Okay, so that's one way that we perceive motion. So we know that as a car, like I try to think about this too with motion perception, like in the airplane. Okay, you know that you're getting farther away because the buildings, the cars, the trees, everything's getting smaller. Okay, and we're moving, okay, in the airplane. I wish I could shut this GIF off. Sorry. All right, here we go. Next part, motion perception. I think that should be letter B. I'm really doing well on the, nope, I'm good, just kidding. Phi phenomenon. Okay, so the phi phenomenon is when we have, it's an illusion of movement. So movement is not actually taking place. So the illusion of movement is going to be, okay, when adjacent lights blink in quick succession. So a light show. Okay, so we're not going to watch this one, unfortunately, but this is a Halloween light show. Okay. How many of you, what Christmas light shows are around here? Is that in Oshkosh? Yeah. Okay, so the Festival of Lights is in Oshkosh. So you have this, all the lights, okay, are adjacent to one another. They blink in different succession, okay, and then the light shows, it's going to appear that the lights are moving.
Can you always just play a song background? Have it in the background. That's so slow.
I'm already done with it. Okay. I'm getting old. Good. So, now, this next one, and I intentionally did an arrow here instead of the letter A, is because I want to explain what constancy is, okay, and then we'll talk about the 4 types. Okay, so perceptual constancy, okay, is when we perceive objects as unchanging. So I'm bringing the strawberry picture back. Yes? What? Yes, it should be 4. I told you I'm winning at this. So number 4, perceptual constancy. Okay, so we perceive objects as unchanging. So the person who put this image together took all the red pixels out of the picture. Okay, so technically we're not seeing red. Okay, our brain is filling that in, and that's going to be something called color constancy. Strawberries are always red. Okay, so my brain knows that, so it fills in the red for me. So the first one we're going to look at is size constancy. shape constancy. Just write A, shape constancy, and then I don't think we really need to write the definition personally, but I guess it's up to you. Shape constancy, with all of these, it maintains the same shape even if the object changes. It's the same size even if it's getting farther away. Okay, so that's what it is, constancy. We know that when we open a door, okay, that when I see the door on the left, the door in the middle, and the door on the right, I know that the door is not changing shape. I know that it's hitting my retina in a different way. So that shape remains constant even though it's varying on my retina. Okay, then we have size constancy. Okay, so objects are still the same size, okay, even when the distance varies. So that's why that one illusion really messed with us, with the man, okay, because if we use principles of depth, okay, so when I look at the monocular cues of relative size, if somebody is farther away and they're the same size, they should look smaller. Okay, but because they were the exact same size but was in the background, okay, my size constancy is thrown off. Okay, so that makes an illusion, which we'll look at here. So here's the first illusion, the Muller-Lyer illusion. So which line is longer? They are the same. Which one looks longer? I mean, the top looks way longer. Okay, so get my trusty yardstick. So 14 inches, 14 inches. Wait, let me go here. 15 inches. Okay, so that's the Muller-Lyer illusion. And this, again, is working on principles. And I would draw these. Okay, so you can see here how they are the same length. And here's what's going on with our brain is we actually perceive it kind of like a corner of a room. So if this is the corner of the room, okay, I perceive it to be going farther away. That it's a corner, gosh, I don't even know if I have examples in here. Okay, the top one I perceive to be more of a corner of a room, but that the corner is farther away from me. Okay, the bottom one would be a corner that would be closer to me. So like the ceiling would look like it was going away. Okay, so that's why it's throwing us off with that depth perception. Okay, the next illusion is the Ponzo illusion. Okay, and this is, with the Ponzo illusion, you could just write the man. I think the other one's even more so than this monster that I had found, that where the depth perception, okay, or our distance cues are being messed with. So these are the same length, and these two monsters are the same height.
Oh, is that like
Yes.
Quinn? It's like those Joker memes now, you know, where the little Joker is.
Yeah.
That's what that is.
Joker meme?
Yeah, there's like these Joker memes where they like stretch the little Joker to make him look smaller.
Okay, I'll look. Okay.
Here, I'll pull it up.
All right, so aside from the stellar fashion here, yes, this is the Ames room. Okay, so the Ames room, what they do, okay, is they're messing again with our distance cues. Okay, and this has to do with size constancy. Okay, so size constancy, if these two are the same size, okay, she almost looks like she's floating, doesn't she? It's kind of weird. Yes. Well, yes, and that's what they do. They draw it to be distorted. So those clocks aren't actually the same size. The floor tiles aren't actually the same size. So you can see here how they actually create that Ames room. Our brain assumes it's a regular shaped room when it's actually not. Okay. All right. So here's the one. Just write lightness constancy. This has to do with light and shadow. A and B here. Okay, when we look at A and B, which one's darker, A or B? But look at this part. A, B. They are the same color. Okay, so here's where the witchcraft comes in, and I printed off some for people, but I guess I can just figure this out. Okay, so we'll have to share. So what I did is I printed this out. Okay, I unfortunately only have an A. Yes. And I had 8 of them, and now I have 5. I don't know what
Someone must have
Okay.
Did you see the
Yes,
video
that's
where
the same thing.
Matt Stoney drank a whole gallon of windshield wiper fluid?
All right. Okay. So you can check this out. What I want you to do, and we'll share as a group. Okay. A and B here are the same color. I want you to flip when you have the sheet. I want you to actually flip, like switch the A and B, and it almost look like it's changing color in front of your face. So you take this, put the A here, and then move it to the B. And it looks like it's changing color. The A, because the A and the B in here are the exact same color.
I don't like that.
It's a variety of things. What?
It looks like
Yep. So when you're done, I'll ask you, to get to that group, and then this will get to this group. They don't.
I'm gonna scream about it.
He's gonna throw up.
Okay, just switch the A and the B. I'm gonna try to have this here.
Goes the A and the one next to it that I shot.
Go ahead and you can move that. Check it out. He's like little. So you're gonna take the A. No. The B. So put it here. Now just switch it.
It's literally gross.
Doesn't look like.
Oh my God, I can see it.
Okay, so let's do the last one. It's color constancy. And that's where we'll end. Color constancy is going to be that colors remain constant. Okay, so even though I may change the filter, I know the apple still is still green. Okay, and my brain keeps it that way. That's the strawberry example. So here's my recommendation to you. Okay, we didn't quite finish. Okay, so actually we'll wait on this because I don't think we'll be able to answer all the questions. So when we come in, I need you to remind me that we need to go over this video, what color is the dress, and I'll help explain why we see blue and black or white and gold.
I